Hello my friends, welcome to this YouTube channel, and today our topic is electrolysis, and we are going to do the electrolysis of concentrated aqueous sodium chloride and dilute aqueous sodium chloride, and we are going to see the difference between the two. So I'm going to write it down here. Electrolysis, and in one case we are doing concentrated aqueous NaCl, and another case we are going to do the electrolysis of, I can say, dilute aqueous NaCl. So see, let us check out the difference. What is the product which going to form at cathode in this case, or anode, and what is the product which is going to form at anode and cathode in case of this one. So I'm just going to write down what are the four ions, or what are the ions that are present in case of concentrated aqueous NaCl. So first you can check it here, that is Na plus, Cl minus, and there is ion also present from aqua means water. So there is a H plus and OH minus. So there are the four ions present in concentrated aqueous NaCl. Same in case of dilute aqueous NaCl, there are the four ions. One is Na plus, Cl minus, and H plus and OH minus. But in case of concentrated aqueous NaCl, there is a more amount of solute, there is a more amount of NaCl present in water. And in case of dilute aqueous NaCl, there is a more amount of water is there, but solute, that is NaCl, is less. That's why this is a dilute solution. So if now what is, if I will write down reaction at cathode, and another case same way, in case of this one, reaction at cathode. Now reaction at cathode, so cathode is a negative charge electrode, so cation is going to move towards the cathode. There are the two cation, one is Na plus and H plus, same Na plus and H plus. Now which cation is going to discharge first? So for this purpose we have to see the preferential discharge of ion. We have a series. I'm just going to write down those name. For example, first we have a potassium, sodium, calcium, magnesium, aluminium, then carbon, zinc, iron, tin, then we have a lead, hydrogen, copper, silver, gold, and platinum. This is for cation. So the I can say that the metal which are at the bottom of the series, this is the reactivity series. So the metal which are at the bottom, they are going to discharge first. Okay, so there are two, I am going to say that there are the two ion, you can check it here, one is Na plus, H plus, and you can see here Na is here, it is at the top, while H plus is present here. So the one which is present at the bottom, that is going to discharge first, and there is a formation of a molecule. So that's the reason why H plus is going to discharge first. So H plus ion, and there is a formation of molecule, so that's the reason why I'm taking 2H plus, and it is going to take 2 electron. Reduction is a gain of electron, and there is a formation of hydrogen gas. 2H plus, that is aqueous, and it is going to accept 2 electron, and there is a formation of hydrogen gas. Same is going to happen in case of dilute aqueous NaCl. So there is a 2H plus ion, aqua, plus it is going to accept 2 electron, and there is a formation of H2 gas. This is called as reduction. There is a gain of electrons, so reaction is reduction. Now move to the another case, that is reaction at anode. I will write down for this one as well, reaction at anode. So anode is a positive charge electrode. So positive charge electrode, so there are the 2 anions, one is Cl minus and another is OH minus. So which anion is going to discharge? So I will just write it down here, the preferential discharge of anion. Okay, I will just write it down in here. What is that? So first is, here we have a sulfate ion, then we have a nitrate ion, another one chloride ion, bromide ion, iodide, and hydroxide. Okay, this is the anion series. So the anion which is at the bottom of the series, like for example this one OH minus, that is going to discharge first. Means they will preferentially discharge the one which is at the bottom, like that here the one which is at the bottom, they are going to discharge first. Same way in case of these anion. So here we have a OH minus and Cl minus. We can see here OH minus is at the bottom. So this is the first rule for anion, and there is another rule that is for anions. There are the 2 rules. One rule is this one, we have to look at this series. Another rule is we have to look their concentration. So if it is more concentrated anion, see, it is concentrated aqueous NaCl, so Cl minus, it is concentrated. So despite of OH minus should discharge first, Cl is going to discharge because this is a concentrated solution. So that's the reason why Cl minus is lose electron, losing electron. So I'm going to write down 2 Cl minus, losing 2 electron and forming chlorine gas. Now look at this one, reaction at anode. Now again 2 ions are there, Cl minus and OH minus, but this is a dilute solution. So for dilute solution you look at this series. OH is at the bottom of the series, so OH minus is going to discharge first. So in this case I will just write it down here, OH minus is going to lose electron. So I will say that here, so 4OH minus is going to lose 4 electron, and it is going to form oxygen gas O2 plus 2H2O, that is liquid. This is a gas. So a reaction at anode, there is a formation of oxygen gas, and what is left behind in this case in your beaker, that is NaCl, while in this case what is left behind is NaOH, because Na is left and here chlorine is discharged, so OH is left. So NaOH is left behind and here NaCl is left behind. At cathode you are collecting hydrogen gas, at anode you are collecting oxygen gas. here hydrogen and chlorine. So this is the difference of electrolysis of concentrated aqueous NaCl and dilute aqueous NaCl. I hope you like this video. So if you are new to this YouTube channel, so please like, share and subscribe. Thank you so much. Take care. Bye bye.